Hello, good day everyone, and today we are going to discuss now one additional problem for this separable equations in our subject differential equation. And this problem is also a board exam problem, and we will go directly to the said problem. So according to this one, we are going to solve for this equation dy over dx equals now to 2y over x, where we have our boundary in which our x is greater than 0 and our y is greater than 0. Okay, so first we need to determine if the given equation satisfy the standard form given by this separable equation, in which, as you can still remember, your dy over dx is just equal now to the function of your x and y variables, and which it is in this form: j as a function of your x times your p as a function of your y. So based on the given, so we have here dy over dx is equal now to the fraction of 2y over this x. Okay, so if we are going to separate this 2y over x, so probably we have this, our j as a function of your x is just 1 over x, and then we just multiply this one with 2y. Okay, so we can say that this one is our j as a function of your x, and this one is your p as a function of your y. So we can say that this is a separable equation. Okay, this is a separable equation. Okay, so by that we are going to separate the variables, so based on this one, so probably dy over this 2y is equal now to this dx over x. Okay, so we have here dy over your 2y is equal now to this derivative of x over this x. Okay, so after this one we are going to integrate, so we will apply directly this integral sign here. We will integrate, and then after we need to extract the constant here, which is 1/2 outside the integral sign. So we have 1/2 times the integral of your dy over your y is just equal now to the integral of your dx over your x. Okay, so based on our previous lecture, the integral of your du over u is just simply equal now to ln u plus c. So in this case, we have here this one is just equal now to 1/2 times the ln of your u, in which your u is just simply your y, the y variable, ln y plus your constant, in which in this case we will consider this one as constant as c1. Okay, and then for this term, integral of dx over x, so we can say that this is simply equal now to ln of your x plus your constant, in which we designate this one as your c2. Okay, so after that one, we need to distribute this 1/2 to each term inside this bracket. So we will have now this 1/2 ln of your y plus 1/2 of your c1 is equal now to ln x plus your c2. Okay, and then after that one is we need to combine to transpose this one of c1 to the other side, so we will have now this 1/2 of your ln y is just equal now to your ln x plus your c2 minus this 1/2 of your C1. Okay, so we have also some property, no, of the natural logarithm for this one, no, this 1/2 ln y, which is just equal to the ln of your y raised now to the 1/2. Okay, and then we have here this ln of your x plus your c2 minus the 1/2 of your c1. Okay, so we will assign, no, a constant value for these two terms here, for the c2 and the c1, in which we will let, no, our c3, no, our c3 is just equal now to c2 minus 1/2 of your c1. Okay, so we will have now this equation here. Okay, so ln x plus your c3. Okay, so after this one, we are not yet done, no, with this. So we are going to exponentiate, no. So exponentiating. Okay, so probably we will exponentiate this term and this term here, so we can arrive, no, with this new equation here. Okay, so this would then become now e raised to the now to your ln of your y raised now to the 1/2. Okay, and this is just equal now to the e raised to this sum, no. So we have here e raised now to the ln x plus your c3. Okay, but as you can observe, no, we have a property, no, for this term here, e raised now to this ln x plus c3. If you can still remember, no, we have some property here in which your e raised to the x times your e raised now to the y is just simply equal now to your e raised now to the x plus your y. Okay, so try to remember this property, no, of this exponentiation, in which in this case we will apply it here. Okay, so this will then become e raised now to the ln of your y raised to the 1/2 is equal now to, take note, this is now the sum, no, e raised to the x plus y, so therefore we can say that this is just your e, no, this one. Okay, raised now to the ln x times your e raised now to the c3. Okay, so after that one, we also have some property, no, of your exponentiation, in which your e raised now to the ln x is just simply equal now to x. Okay, so in this term here, e raised now to the ln y raised to the 1/2 is, our x here is just simply this y raised to the 1/2. So we can say that this is just equivalent to y raised now to the 1/2, and then e raised to the ln x is just simply x. Okay, so this is x. Okay, times your e raised now to the c3. Okay, so any constant, no, e raised now to any constant is just a constant itself, no. So we will assign here, no, this we have c3, so we will assign here c, no, we will assign c4 is just equal now to the e raised now to the c3. Okay, so we can have now this new equation here, x times your c4, or we can say that your y raised to the 1/2 is just equal now to c4 times your x. Okay, so after that one, we need to simplify, no? To simplify, because we still have an exponent of your variable y. So if possible, you will have your variable y, no, raised to a single exponent. So in this case, still we have 1/2, no? So we have to simplify this one, no? And then after that is your y raised to the 1/2 is equal now to your c4 times your x. So we just have to multiply this one with the exponent of 2, no? So that your y will have this a single power or exponent of 1. So in this case, y raised to the 1/2 times 2, so this is 1. So we just write here y, and this would be equal then now to your c4 squared times your x squared, no? Because this exponent is distributed to this c4 and this x. Okay, so after that one, we will assign, no? We will assign, let, since we are on this final equation, so we will assign, no, this c is equal now to the c4 raised to the squared. Okay, so this would be then equal now to y is equal now to c times, no, times your x squared. Okay, so we have arrived, no, to this equation y is equal now to your cx squared. Okay, so this would be now our final answer, no? This y is just equal now to c times x squared. So you may wonder, no, why we are not using this x greater than 0 and this y is greater than 0, because first, no, we don't have an exact value of your x, no, and also for your y, we don't have an exact value of your y. But if ever, no, in our future problem that x has an exact value, same also for the y, so you can substitute, no, your x here and your y here, so that you can get your constant, no? So in this case, you may get now your c4 raised to the squared, but since your x must be greater than 0 and y must be greater than 0, because the main reason for that is so that this problem is not an undefined problem, no? Because if your x is 0, so we cannot probably solve, no, this given equation. So that is why there's a condition that your x must be greater than 0, and also for your y must be greater than 0, because if your y is equal to 0, so still we cannot solve this problem. So that is why your x and y must be greater than 0. Okay, so again, no, I will reiterate, if the problem gives you a specific value of your x and y, so you can substitute it here, no, even at this point of y equal now to c4 raised to the squared times x squared, you substitute it here. Okay, and then after substituting your x and y, so you can get your specific value of your constant. So you can substitute your constant directly, no, to this one. So you will have, no, numerical value of this c here if ever that you have a specific value of your x and your y. Okay, so this is now the solution, no, for this given equation. Dy over dx is equal now to 2y over x, where we have this condition that your x must be greater than 0 and your y also must be greater than 0, so that we can solve this given equation. Okay, so thank you for listening, no, and watching this lecture video of mine, and I hope you get something out of this lecture video. And I'm hoping to see you again for my succeeding lecture video discussing with you how to solve differential equation problems. Like in our case today, we are tackling separable equations, and we are going to solve the given equation. No? So once again, thank you, and do not forget to subscribe, and then God bless everyone. Keep safe also.